Hey everybody, welcome back. Today we are going to be talking about Chapter 8, all of Chapter 8 today. And there's several different pieces of Chapter 8, but let's get going, get this review done. I hope this jogs your memory a little bit. If you have any questions, make sure that you do ask. Ask me when you see me next, all right? So let's get going. All right, so things to know, things that you should be remembering from Chapter 8. Chapter 8 was the beginning of our polygon work. Okay, we started dealing with things like equilateral and equiangular. We started dealing with what a polygon is. This was the same chapter where we dealt with concave and convex polygons. We classified different polygons. We started figuring out angles inside polygons with the interior and exterior angles theorem. Okay, these two theorems, remember the interior angles theorem is n minus 2 times 180, n being the number of sides we have because we're figuring out our diagonals. Remember, we find our diagonals and we multiply by 180. Exterior angles theorem, it does not matter what shape it is. It could be a pentagon, or of course needs to be a polygon, but it could be a pentagon, it could be a heptagon, it could be a dodecagon. Whatever it is, our exterior angles theorem means that the exterior angles add up to 360. So remember, it could be, those are the extended ones that look similar to this. Okay. And all of these shapes, all of these angles here would add up to equal 360. Okay? Then we started talking about area and perimeter of different shapes. This is the chapter where I gave you a shaded figure with rectangles stacked onto squares or trapezoids stacked onto triangles. And we started figuring out what was the area of each shape. There were several formulas there. If you want to know what those formulas are, we'll go over them quickly right here. Okay, triangles. I'm just going to write a T for triangles. Your triangles. Actually, you know what? I am going to start a new page here. So your triangles piece. Okay, remember that formula for area, again, this is all area, is going to be half times base times height. Okay, then we started dealing with parallelograms. Okay, and the idea behind parallelograms is just like it is for rectangles and squares, because those are parallelograms. You take your base times height. Then we moved into trapezoids, and I think trapezoids was something new. You should have already known triangles. You should know parallelograms, but that is going to be your half times your height, and then you add your B1 and your B2. Remember, it has two completely different bases, so you add those two bases, multiply it by your height, then divide by 2. And lastly, we talked about circles in this chapter. Circles meaning the area, okay, the area being pi r squared, to figure that out. And again, that was area. But then we also talked about circumference, circumference being the perimeter of a circle. Okay, that's different, and that's 2 pi r. That's different than every other perimeter for triangles and parallelograms and trapezoids, because for those other objects, you just add up all around. But for circles, you have to take 2 times your pi times your radius, or you take pi times your diameter. Okay, so get to know these formulas. I'd focus on the ones that you don't know. Something like trapezoids might be something that you just need a little bit refresher on. You should already know triangles. I hope you know parallelograms. Circles, you might need to go back and just redo, maybe do a few problems. But just get your mind thinking about these different formulas, okay? This final, I told you earlier that this final is very formula heavy, so be prepared to manipulate different formulas. All right? So let's go through a few problems. Okay, so you're going to be labeling each figure as equiangular, equilateral, regular, or none. Again, this video is for your benefit. It definitely will help, but it's not needed to write down these shapes. If you just want to write down the answer, that's fine. I'm going to give you a moment to pause and try this one in just a second. But remember, this video is not required. Okay, so pause now, give these three a shot, see what you remember. All right, so equiangular, equilateral, regular, or none. Well, we know equiangular, that word equiangular, it's angle. Notice angle, not spelled correctly, but angle is in there. That means equal angles. Okay, equal angles for equiangular. All angles are the same. Okay, then we have equilateral. Equilateral means equal sides. Okay, all sides are the exact same. Lastly, we have regular. What regular is, it's both. Okay, it's both equiangular and it's equilateral. So if all the sides are equal and all the angles are equal, it is known as a regular polygon. Last, we also have none. And that's going to be if none of these are true. So these three shapes, I'm going to label this 1, 2, and 3. The very first shape, if you notice, we have congruent sides. We do have congruent angles. But notice about these angles, okay, these two angles are not equal to all the other angles, okay, based on their angle segments or angle markings. Okay, so it cannot be equiangular. Is it equilateral? No. Okay, because this side, this third side right here, or sorry, not third side, this fifth side right here is not equal to all the others because it does not have all equal angles, because it does not have all equal sides. It is none. Once we rule out equiangular and equilateral, we can automatically say it's not regular because they need to be both of them. Okay? Second one. Notice looking at all of these shapes. All of these sides. Okay, all of the sides are congruent. Then you look at all of these, so we know it's equilateral. But if you look at each and every angle, they're also congruent. All angles congruent, all sides congruent. This is a regular polygon. So that would be regular. Last but not least, we have the third one. And notice we have no information about the angles. So because we have no information, we cannot assume that the angles are congruent. We can't do that. There's no angle markings. There's nothing to be known about the angle, so it cannot be equiangular. However, all of our sides, if you look at all those sides, they are equal because we have equal sides, but not equal angles. It is equilateral. Okay, awesome. I hope these terms are jogging your memory a little bit. Let's keep jogging and moving on to the next slide. All right, so now we're going to find the measure of the missing angles. So if you look at this, what type of angles are we given? Well, we're given exterior angles. All of these are on the outside of our shape because we're given exterior angles. What do we know? What theorem do we know? Well, we know that they have to equal 360. Excellent. So knowing that they have to equal 360, I want you to give this one a shot and see how you do. Alright, so now if we do this, we're going to plug this into our formula of 95 plus 85 plus 2x plus x is equal to 360. Well, 85 and 95 is equal to 180 here. So we're going to subtract 180, and we get 3x is equal to 180. Once we divide here by 3, we get x is equal to 60. So because x is equal to 60 degrees, don't forget your labels, we know that that is equal to 60. However, we also have an angle that's 2x. Well, if x equals 60, 2x equals 120. And that's going to be this angle right here. Okay, we added up our angles. This exterior angles theorem, you just might need a little refresh, but exterior angles theorems means we add up all of our exterior angles, exterior meaning outside our polygon. So when you look at this, we added all of these up, we set them equal to 360. It does not matter if it has 3 sides, it does not matter if it has 27 sides. Whenever you have exterior angles theorem, they always add up to equal 360. We did that, we solved for x, plugged x back in for the 2x, and we're done. Bingo, bango, bongo, done! Awesome. Okay, now we have interior angles. How do you know if they are interior angles? Inside. They're inside. We have inside our shape. So, because they are inside our shape, I want you to give this one a shot. See if you can figure out the interior angles. Alright, so now interior angles theorem states we need to use a certain formula. That formula is n minus 2 times 180. Okay, so we have to figure out how many sides we have first. Okay, so we look at this. We have 1, 2, 3, 4, 5, 6, and 7. So 7 sides. So we take this and we take 7 minus 2 times 180. Well, from there we would take 7 minus 2, which is 5, and then take that times 180 and we get 900. So once we have our interior measure, we now plug in the angles we know. Well, we know x because we're trying to find this angle right here. We know x. We don't know what it is, so we're just going to plug in x. Plus 140, plus 140, plus 90. This is a 90-degree angle. Plus 130, plus 150, plus 120 equals 900. Okay, so when you take 140 plus 140 plus 90 plus 130 plus 150 plus 120, do all of that, you get 770. Okay, so all of these angles equal 770. And as you're noticing, it turns into just simple algebra. Okay, you subtract 770 from each side, and you get x is equal to 130 degrees. Okay, again, we use that formula that we know. We manipulated this formula into something we could use. So we plugged in n minus 2 times 180. We solved, and we got our answer of 130. Okay, make sure, again, it is our last test in geometry. I shouldn't say our last test because we may have a test afterwards, but probably not. But notice our labels. Our labels are degree symbols. Make sure you put those in when looking for an angle. However, if I'm looking for a side, I should not see that angle symbol, okay, or that degree symbol. All right? Awesome. All right, so now we are finding the area of the figure. Now we're going back into the different shapes and the different pieces that we know of, okay? So if you remember your formulas, use your formulas, try to figure this one out. Once you do, we will talk. Give this one a shot. All right, so when you do this, notice we have two shapes here. So when we do this, okay, you will notice we have a trapezoid and we have a rectangle. Okay, so if I take those two area formulas, I figure out the area of the rectangle, then I could figure out the area of a trapezoid and solve. Okay, so I'm going to figure out the area of this rectangle first. Area of a rectangle, okay, I'm just going to put R for rectangle is base times height. Well, we know that the height is 16 inches, and we just take that and we multiply it by 20, and we get 16 times 20, which is 320 inches squared. Remember, area is always inches squared because we take inches times inches. So very easy rectangle is you just take 320 inches squared. Now, we get into the trapezoid. Why do we know it's a trapezoid? All right, well, if you look at this, we have parallel sides. One set of parallel sides here tells me that that is going to be a trapezoid. All right, so now because of that, we need the two, if you remember our formula of a trapezoid is half times your height times B1 plus B2. When you do that, what's B1? Well, it's 9. I know that this base right off the bat is 9. What's B2? Well, it has to be 20 because again, this is a rectangle, so 20 inches here. This has to be 20 inches because it is a rectangle. Now the question is, what's the height? Well, we know the entire height of this shape is 21 inches. Well, if we know that the rectangle stands on 16 of these inches, we know the remainder, if that's 16, the remainder has to be 5 inches. So the height of that trapezoid is 5 inches. Even though it doesn't look like 5 inches when compared to 16 inches, it is. Okay? It's not drawn to scale. We'll say that. Okay, so this is 5 inches, and then we're multiplying it by half. So when you do this, okay, you take 9 plus 20, which is, of course, 29. Then you multiply that by 5, and then divide by 2. So when you do that, you get this shape is 72.5 inches squared. Again, it's still inches squared. So I found the shape of the rectangle. I found the shape of, or found the area of the rectangle, found the area of the trapezoid. What do I do now? Add them together because the entire thing is those two added together. You take 320 plus 72.5 and we get 392.5 inches squared. All right? Awesome. Moving on. Okay, last one of the day, what I want you to do is I want you to find the area. Okay, so remember the area of a circle, and I want you to try to solve this one. All right, so now we know that the area of a circle is equal to area equals pi r squared. Well, we're given the diameter, not the radius. So what do you know about the diameter? Well, it's twice the pi. So in order for us to find the radius, we just take pi times 7 squared. When we do that, we get 49 pi. Okay. Then you have to take 49 pi on your calculator. Make sure that you actually type in and hit pi. Okay, so you will get, if we rounded it, let's say round to the nearest tenth, you get 153.9 centimeters squared. Something very quick once you know the radius. If you know the radius of the circle, you can figure out pretty much everything. All right? How about, what if you found the circumference? Well, another question doesn't ask us, but what would the circumference be? Well, if you wanted circumference, you would need to take 14 times pi. Okay, because remember it's pi 2 pi r. Well, 2 we already have the diameter, so why do that? Multiply it again, and that would be 44.0 centimeters. Again, perimeter has 1 unit, area has 2. Okay, so just remember the different formulas. We're going to get really formula heavy here in our next review, but just to help you remember, there's that interior angles formula, know about exterior angles, but also know the different areas. Okay, have a wonderful day. Bye.